In section 2.4 here, we're going to go ahead and take a look at using postulates and diagrams. And so the idea is that at the end of the lesson, you'll be able to identify how and when to use certain postulates regarding points, lines, and planes. Now, as I explained in class, the front side of your notes there, the whole front page, are theorems and postulates that you should already be familiar with. So I'm not going to go back over those. You can kind of go over those on your own and identify any that you're not sure of, and then we can revisit those in class if need be. Okay, just a quick reminder here. Axiom and postulates are very simply rules that are accepted without proof, and theorems are rules that are proven. Okay, can be proven. So again, you have the segment addition postulate. Okay, and I'm not gonna actually take the time to write these up. You know this, okay? So a lot of these notes we're just gonna buzz right through. Angle addition, you should already know. Okay, postulate 5 through any 2 points, there exists exactly one line. Should know that. A line contains at least 2 points. Again, nothing crazy new here. If 2 lines intersect, their intersection is exactly 1 point. We've talked about that back in chapter 1. Through any 3 non-collinear points, there exists exactly 1 plane. Again, nothing new. If 2 points lie in a plane, then the line containing them also lies in the plane. 2 planes intersect, their intersection is a line. A linear pair are 2 angles that are supplementary. Okay, or really, a linear pair by definition, that's actually the linear pair postulate, which we haven't, I guess, formally introduced yet. But a linear pair is very simply 2 angles that form a line. And the technical definition is that they are 2 adjacent angles with one side being a set of opposite rays. Okay. So again, theorems and definitions. Definition of midpoint, should be familiar with that. I'm going to go ahead and buzz through all these. These are all things that you should be familiar with. Angle bisector, supplementary angles, complementary angles, vertical angles, perpendicular lines, right angle. Right angle congruence theorem simply states that all right angles have to be congruent. Should make sense, seeing as how all right angles have a measure of 90 degrees, and if 2 angles have the same measure, that means they're congruent. So the right angle congruence theorem simply means that all right angles have to be congruent to each other. Segment congruence, all right, if they have the same length. Angle congruence, if 2 angles have the same measure. Okay, a line is perpendicular to a plane. Okay, so now we're on the back side here. A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. Okay. So example 1 says state the postulate that's being illustrated. All right. If 3 points are not collinear, okay, so if you have 3 non-collinear points, then they determine a plane. Okay. So 3 non-collinear points determines a plane. So again, for if then there, if 3 points are not collinear, then exactly 1 plane can be drawn through them. Okay. State the postulate illustrated by the diagram. If then, so you'll notice here you have 2 lines intersect. Then, and this thing right here is kind of bolded. So if 2 lines intersect, they intersect at exactly 1 point. If 2 planes intersect, their intersection is a line. Again, I'm going through these quickly because these are things that you should already know. Okay. Example 2 says sketch a diagram showing RS perpendicular to TV intersecting at point X. Okay. So RS is a segment. RS. TV is a line. They intersect at point X. And they are perpendicular. I probably should have drawn this more to scale then, so I'm going to erase that. My apologies. Okay, so here's segment RX, or RS, I mean. TV, point X. Now here's the deal. Right now they appear to be perpendicular, but until I tell you that that's a right angle, you cannot assume that. So you must have a right angle there. All right. Sketch a diagram showing line TV intersecting segment PQ at point W. Okay, so here's PQ. Doesn't matter. Again, you can draw this any way you want, but segment PQ. Line TV intersects at point W so that TW is equal to WV. So in other words, when I draw this, here's T, here's V. They intersect at W, and it says that TW is the same as WV. They're congruent. So again, as long as your diagram shows that they're congruent, we can conclude that, okay, and it fits in. All right, what can you state from the following illustrations? Okay, use definitions, theorems, or postulates to justify, okay? So I look at this guy. Okay, what can I conclude? Angle A and angle B form linear pair. How do I know that? Definition of linear pair, right? They form a line, right? These two sides are opposite rays. They're adjacent to each other, so that's a linear pair. And this is kind of getting into this idea of proving something, okay? The second thing here, okay, Q's between E and W, so I can say that EQ plus QW equals EW, and that is the segment addition postulate. All right, take the two smaller pieces, add them together, got to equal the whole thing. Okay, what can I conclude? I can conclude that B is the midpoint of segment AC, and the reason, definition of midpoint. Right? What does it mean to be the midpoint? It means you lie directly between these two guys, and we know that because of these marks here. Okay, so again, this is the idea of proving something. You make a statement, and then you justify that using a definition or theorem that you already know to be true. Okay, so we're using facts. This is deductive reasoning. We're using theorems that have been proven. Okay, so here I can use the angle addition postulate. So angle, the measure of angle KLB, KLB, plus the measure of angle MLB equals the measure of angle KLM, the whole thing. The reason, angle addition postulate. All right. Now again, at this point, I'm going to go ahead and let you guys kind of work through the other two, or I guess there's more than two. There's 5 of them there. Okay. I'm going to let you work through those, and then you'll bring in the class, and if we have any issues, we'll take those. But use the definitions and theorems from the front page of your notes to justify. Okay. Provide a statement, and then justify why that statement has to be true. I'm going to skip through these next few. Okay, so now we have to sketch a picture. Okay, and again, I'm going to do some of these, but you're going to be expected to do quite a few of these on your own. Okay, so we're going to sketch a picture, and then give a statement, and then give a reason. It says X is between Y and Z. Okay, X is between Y and Z. Y, Z, X is between them. Okay, statement, and this is, again, what am I going to use? I'm going to use segment addition. YX plus XZ equals YZ, segment addition postulate. Okay, so again, just kind of getting your feet wet with this idea of proving something. Okay, point B is the midpoint of AC. AC, point B, tick, tick, right? Those are congruent. And so now what we can say is we can say that AB is congruent to BC, definition of midpoint. Okay, so again, just using theorems, definitions, things that you're already familiar with to justify. Okay, so you're going to make a claim, and I've told you this over and over again, geometry is vastly different than any course you've taken up to this point, because you're not going to be able to just tell me something. You're going to have to justify that every single time. Okay? All right. So again, I'm going to do a few more here. I'm trying to look here to see if there's any more that are maybe a little bit more difficult or relate to something that we haven't stressed lately. Let's see here. Let's go ahead. I'm going to go over to the vertical angles one. So I'm going to scroll over. All right. So two lines that intersect, and then angles on opposite sides. So I can call this guy 5 and this guy 8. All right, and so the statement is just going to be exactly what we just saw. Angle 5 and angle 8 are vertical. And I know that because of the definition of vertical angles. Okay? We have adjacent angles, so I know they got to be angles that are next to each other, so I have, let's see here, S, T, U, U, T, W. Okay? And so what you're going to say is very simply, these two angles are adjacent, so angle STU is adjacent to angle UTW, and that's just definition of adjacent angles. Okay, and again, as you're going through, you can use symbols to help simplify some things. Okay, and then finally, you know, I'm gonna let you guys kind of finish these notes up on your own, and just use again the definitions and theorems and postulates to justify your diagram and your conclusion. So hopefully this is a pretty good intro in terms of what proof writing is going to look like. Make a claim, justify it using a fact, and again, just get your feet wet here, and any questions you have, bring them first thing in class.